Dear partner, welcome to the MAQ family. In the coming 20 minutes you will get to know a lot more about MAQ tools and the unique STMD technology. Our objective is to give you the best possibility to achieve great results for you and your customers. If you have any questions after this training or when you have a customer case, don't hesitate to contact us. We're all here for you. Let the show begin.
Hi, my name is Shilling and I'm one of the founders for the company MAQ and also taking the position as CTO in the company. In the year 2015, I earned my PhD degree in the area of mechanical engineering, focusing very much on how to reduce the vibrations in metal cutting process. 2016, I founded the company MAQ together with my two professors, and 2018 we sold our first unit. In the year 2019, we started to have the serial production, and up to today, we have sold over 7,000 units on the world market. I have a genuine interest in scientific topics, and I have a vision to simplify machining for the operators who work in the shop floor. The challenge we were facing back in the days is that, as one example, if you buy two identical machines from the same brand and they get delivered to your shop floor in the same time, and they're just going to have two different performance when it goes to real production. There are several theories trying to explain the reason why, and what we are looking at is the vibration frequency in those machines, and we said the challenge was the varying vibration frequency during machining. As one example I'm showing here is a 20mm turning tool, and we put in the machine at different aperture ratios from 6 times the diameter, 8 times the diameter, and 10 times the diameter. And if you are able to measure the most prominent vibration frequency, you will realize that the vibration frequency of the tool actually change constant when you change the L by D ratio, and that was the challenge we're looking at. The tool has a varying vibration frequency. If you have a fixed vibration frequency, it's relatively easy to find a solution because you just need to work against that particular frequency. But when your frequency is always changing, then you need a solution that can adapt or change itself when you have a change in the vibration frequency in your cutting process. The solution we're presenting today is a self-tuning mass damper technology, or called STMD, on the market. It composes a mass, usually made of a tungsten, which is quite heavy, supported by polymeric materials. And the unique feature for the solution is that it's made for immediate usage, meaning that you don't need to make any adjustment when you put it into the machine. And the damping mechanism inside the tool actually can adapt itself to the changed vibration frequency in your machining process. And the advantage coming out from the technology is that all of a sudden the tool equipped with the STMD solution actually has a much wider operation window compared to your previous products. So let's make a comparison with the most dominant solution on the market, and the STMD. So on the left hand side of the picture you see a solution where it also has a mass damper inside the cutting tool, and the mass is supported by rubber rings, and they have put the viscose oil inside the cavity between the damper and the tool to enhance its damping efficiency. If you take a close look at the rubber material and look specifically at its stiffness, it has pretty much a constant elastic modulus over the frequency range we are interested in. And on the contrary, what we have done comparing to the most dominant solution on the market is that we have taken away the viscose oil, so the solution for STMD is purely dry. There's no risk for leakage in the product. And we have replaced the rubber rings to the polymeric materials that we have in the STMD technology. These polymer materials has nanostructures inside them, which allows them to have a changing stiffness along with the frequency. So when your frequency is increasing in your machining process, these polymers, they get stronger and tougher, stiffer, so that you can change the vibration frequency of the damper to make a match. And when your frequency in the machining process is actually decreasing, then these polymers, they will get softer to make a fine adjustment of the vibration frequency from the mass damper to make a match. So all of a sudden you have a passive solution, but you have achieved an active function to make sure that your damper today is fine adjusting itself to make a match to your changed vibration frequency in your cutting process. If we make vibration measurement of the tools and we look at how much the tools will vibrate under an impact force, and here I'm showing the comparison results where I put a 25mm product into the machine and measure its vibration displacement along with the frequency. So the x-axis represents the frequency y-axis represents the amplitude, red curve represents the competition product, and the green curve represents MAQ product. And you can see that when we changed aperture ratio from 6 times the diameter up to 9 times the diameter, independent of the aperture ratio in machining setup, MAQ constantly achieve a lower vibration amplitude between 25 up to 45%. And this actually means if you put the MAQ product into action during metal cutting, the MAQ product, the STMD technology, will have 25 up to 45% higher productivity. We have also done a lot of machining tests comparing us with the most dominant solution. And here I'm presenting the machining outcome if you put the two at different aperture ratios and with the constant cutting speed or depth of cut, but you just change the aperture ratio and the feed rate. And what you could see here is that if the machining was stable, it's going to be a green cell. If it's yellow, it means there was some slight vibrations, but it could be acceptable. And if it's red, it means there was a so strong vibration they have to stop machining. And the result shows that if you choose the MAQ product, you make a blind test, meaning that you select a random cutting combination here, you will have 92% success rate, whereas if you choose the competition product, you can only have 45% success rate. So this is what we mean by a wider operation window. If you choose the STMD solution from MAQ, you will have a wider operation window for you to serve your machining case. Here comes the result of the surface finish that we have done during the metal cutting process, and you can see that independent of the air-body ratio in the setup, the STMD solution from MAQ constantly produces a better surface finish compared to the next best alternative. And this is also what our customers normally tell us, that when they switch to the STMD solution, they don't hear much of a sound difference in machining, but once the workpiece comes out from the machine, then they can really see that the STMD solution constantly make a better surface finish for them. So as a summary, here we talk about the early market feedback. People normally say that they have a much higher success rate when they switch to the MAQ STMD solution. They also realize that there's no need to adjust or compromise the cutting data to make the two to work. That means they can basically use the recommended cutting speed and parameters from the cutting insert. So the two of a sudden is not a limit anymore in the production environment. And we also learned that the competition solution on the market actually has their sweet spot, meaning that they are fine-tuned for certain frequency range. In this range, they have more or less the same performance compared to the STMD solution. But as soon as the machining condition move away from their sweet spot, then the STMD solution will show its strength, adjust itself to make the fine-tuning, increase its damping efficiency, and get better results. And we have also learned in the past that the clamping of the tools is also critical when it comes to a challenging condition. In this section, we're going to talk about how to use the MAQ products. When we look at the clamping, which is a critical factor to have a success in machining, we have summarized a few types of clamping commonly used by end users on the market. The first one is the direct screw mount, meaning that you have screws mounting directly onto the cutting tool. And that solution is not recommended by MAQ, but we are aware that some of the customers actually use this type of clamping because they use the tool for very short setup. But remember, MAQ does not recommend that. To start using the STMD solution, we recommend the customer start by using the reduction sleeve that we have in our standard portfolio. This reduction sleeve will protect the damper package inside and also provide sufficient clamping for most of the applications. If the customer has more budget, then we recommend the customer to take a look at the all-around clamping solution that has a much higher clamping rigidity compared to the other ones. If the application is using a tool that is extra long, then we recommend the customer to invest in the hydraulic fixtures. And these hydraulic fixtures has a very short clamping length with quite a high clamping rigidity. But keep in mind that the hydraulic fixtures has a quite high tolerance requirement both on the tool and on the fixture that you have on the machine. When we speak about the all-around clamping or using the split sleeve clamping, there are certain things we have to be aware of. There are these type of fixtures that has the VDI back interface, and it actually has a slot where the tool is going to be clamped. And these fixtures were recommended or marketed as a good solution to clamp the vibration damper turning tools. But actually, because of the slot that is present in the product, it has reduced the overall rigidity of the fixture by half. So that is not really good for vibration damper turning tools. If you have a challenging condition that is strictly forbidden to use, it will create a lot of problems for the end users. And the general condition is that use a short and sturdy fixture which will have a higher rigidity compared to a long and a slender fixture. To align the product into your machine, there are several ways to do it. The most easiest way is that to use the groove that is available on the product together with the reduction sleeve from MAQ. Once the plunger bolt goes into the groove, that means the tool is already aligned. And the second solution is that you can make use of the digital spirit level, which can measure the angle of the teething for the cutter head. That means you use the digital spirit level to measure the alignment of the guideways on the turret first, and use that as a reference to mount it on the cutter head until you find a zero. All of the cutter heads from MAQ has a substantial flat surface which can use to make alignment using the digital spirit level. Let's take a look at MAQ product portfolio in the turning tool sector. We actually have the standard portfolio from 6mm up to 80mm in stock, equivalent of a 1/4 inch up to 3 inches in stock. And we actually have the world's smallest vibration damper tool with a 6mm diameter or 1/4 inch used for 10 times D applications. If we take a look at the portfolio, you can see that we actually have a 5 times D series product, which is aiming to replace the carbide tools on the market to enhance our end users to increase their productivity by reducing the vibrations in a short tool setup. Between 8mm up to 12mm, we also have the solutions that can cover up to 10 or 11 times the diameter that has a coolant going all the way through that can cool down the cutting process and increase the lifetime of the insert. And for the standard diameters from 16 all the way up to 80, we have the 15 times the product, where MAQ is taking the lead in the longest tool on the market. Since last year, MAQ has introduced the diamond burnishing product series. And it's a diamond burnishing tool that you first make a turning process to reach a relatively okay surface finish, and then you do a diamond burnishing process to reduce the roughness of the surface down to 0.3 or 0.2 even micrometer in the surface finish RA. This is bringing tremendous value for our end users. When you use the MAQ product, it's quite important to remember that use the screws that comes together with the product. There are holes which is on the serration lock interface which is exchangeable to the other brands. If your screw is too long, it will not be able to clamp the cutter head in a rigid way, so that during machining, this cutter head can get pushed away from its original position and leave a mark on the surface of the workpiece. When it comes to select the cutting parameters, there are a few things that we need to be aware of. The first is that choose a cutting depth that is higher than the edge radius on the insert. That means you want the insert to cut into the material instead of ploughing on the surface of the workpiece, which creates a lot of vibrations. A typical edge radius of a carbide insert is roughly 50 microns, so start with a depth of cut that is higher than that. And the second is that choose a feed rate that is higher than the edge radius. So again, the feed rate has to be higher or larger than the edge radius of the insert. And when we talk about feed rate, we also have to consider the corner radius or nose radius of the insert. We should use a feed rate that is higher than 1/4 of the nose radius. For example, if your nose radius is 0.4 mm, then your feed rate should better stay above 0.1 mm per revolution. If your nose radius is 0.8 mm, then your feed rate has to be maintained above 0.2 mm per revolution. This is to reduce the tendency to vibrate during machining process. Please also be aware that the feed rate actually has a decisive factor on the surface finish of the machining workpiece. On all MAQ products that we ship out today, we will include this kind of flyer in the package. This flyer actually contains most practical information for the customer to make a success with the MAQ products. And in one of the sections, we have highlighted the suggested starting parameter for regular machining process, and based on different materials as well. As an example, in machining regular steel, we recommend that you start with a cutting speed which is moderate at 200 meters per minute, with a depth of cut, let's say 0.5 millimeter in the radius, and a feed rate, let's say around 0.15 or 0.2 millimeters per revolution if you have a nose radius 0.4 millimeter. Take a look at the user manual. It contains important information that makes a step-by-step guidance for you and your customer to achieve success by using the STMD solutions. When we deliver the STMD solution to the end customer, there are certain things we need to be aware of. What we have done basically is that we have made a hole into the front of the tool structure, and inside we embedded a high intelligent device. That means we have thin sections on the product. These thin sections has a lower load carrying capacity compared to a standard steel tool holder, so that we have engraved the maximum allowed load on the cutting tools, and that should be respected. When you use the product, make sure not to exceed a certain temperature, which is 100 degrees in our products, because a higher temperature tends to melt the polymer materials inside. And these are the two things we need to be aware of. So use coolant during machining to control the temperature and to respect the maximum load on the cutting tool.
One question we often get when a new partner joins us is, where should we start to look? Who should we approach? Listening to our partners, we can give you some recommendation where to start. Aerospace industry has very strict tolerance requirements for parts used in airplanes and spacecraft, as well as high levels of accuracy. To achieve these requirements, vibration dampening tools are essential. The defense industry has always high requirements on surface finish, precision, and tolerances, and you can definitely find need for MAQ tools and tool holders here. The energy industry is another sector that need vibration dampening tools because of the high requirements on surface finish and often complex operations. And then we have suppliers and sub-suppliers. Many companies in this sector meet very tough requirements and performs a wide variety of operations. They can really benefit from the flexibility that MAQ tools can offer.
Since we released the STMD solution on the market, we have achieved a lot of great success because we pushed the boundary of machining for the end users. If you have great success stories, please share with us.